Right, we're just going to go through the derivations of the equations of motion, just to look at where they come from. Now, the first one just comes from the definition of acceleration. That acceleration, so this is number one, acceleration equals change in velocity over time taken. So, from that, we can say that acceleration, change in velocity, is the final velocity, which we're calling v, minus the initial velocity, which we call u. We divide that by time. We cross multiply. At equals v minus u, and then just rearranging that and making v the subject, v equals u plus at. So effectively, that first equation of motion is just the definition of acceleration rewritten. The second one, we know that in general, displacement or distance, we might say, is speed times time. So here we'll say displacement equals average velocity times time. How do we work out the average of something? We take the initial and the final values and we add them together and divide by 2. So u, initial velocity, v, final velocity, divide by 2 and multiply that by t. S equals average velocity times time. There's the second equation, as simple as that. The third equation, let's start with S equals u plus v over 2 then times t. So that's our second equation. And we've also got v equals u plus at. And so where we have got v in this equation, we're going to substitute that term in place of it and then just do some simplification. So u plus at, that's v, all divided by 2 and all multiplied by t. S equals, let's hold it, the all multiplied by t is that whole thing there. We've got to be a little bit careful of that. So let's multiply that out now. U here times t is ut. Let's leave the 2 in there for now. And then we've got u here times t, so we've got another ut. And we've got at times t, at squared. So S equals 2ut plus at squared, all divided by 2. And then if we divide the 2 into each of the two terms on the top line, 2ut divided by 2 becomes ut. And at squared over here divided by 2 becomes a half at squared. Right, the last equation is really arrived at just through a bit of playing around. A equals v minus u over t. That's the first equation, just with a as the subject. And S equals u plus v over 2 times t. That's the second equation. And we're just going to randomly, you could almost say, choose to multiply a times s. If we multiply a times s on the left-hand side, on the right-hand side, v minus u over t, multiplied by u plus v. I'm going to make a slight change immediately, v plus u over t, just swapping the v and the u over for a reason, times t. As equals, now we've got a product on the right-hand side, multiplication here, so that t and that t effectively can be cancelled out. And what are we left with? We've got a 2 on the bottom line over here. So let's choose to take the 2 up over here. So we get 2as, and that equals, so that's a little bit in the way, so let's just get that out of the way, v minus u over v plus u, and all you wonderful mathematicians will recognize that as a difference of 2 squares. So 2as equals v squared minus u squared. And so if we make v squared the subject now, v squared equals u squared plus 2as, put v on the left, v squared on the left-hand side. All right, so that's the fourth of the equations derived.